So I have the pleasure to welcome you in the Amazon headquarters. I'm working for AWS. I'm working a lot on Lambda and Serverless and Swift and EC2 Mac and all Apple-related technology for AWS. How many of you heard about AWS Lambda? Oh, majority. Keep your hands up. How many of you are actually using AWS Lambda? Okay. So I'll start with a brief crash course on AWS Lambda. The goal is to not sell you AWS Lambda, but to let everybody catch up the train and so that you can follow the rest of the talk as well. We are not too many tonight, so don't hesitate to interrupt me, ask me questions during the talk, after the talk. Still a bit of pizza and Coke. Yeah, all the bottles that you could not open because there is no opener. Sorry for that. That's the one thing I forgot tonight. Anyway. I'm from Belgium. I usually speak French. You might have noticed a slight touch French accent. So you will have a variety of accents tonight. So server-side. What is server-side? I guess you are all Swift developer or working with Swift, iOS application, iPadOS application, and most of your application have a backend. So you call the backend from your application. When I developed my first iOS application, it was 2009 in Objective-C, iOS 2, I think at the time. I had to actually install the backend myself. So I had to rent a Linux server somewhere, connect to it, install PHP. No, it was not PHP, it was Python. I installed MySQL, maintain that, restart MySQL when it crashed, develop an alarm system because none that I know exist. And that's all undifferentiated task that doesn't bring any new value to my application. And so the availability of the server side was a problem. And fortunately, my application was never successful. Otherwise, I would have another problem, is to scale that. I need 2 servers, 3 servers, but then I need a load balancer in front of that, and then I add extra complexity to that. So fast forward to 2023, we as developers, we don't need to think about server-side anymore because someone else can manage that for you, and that's the idea of server-side application. In your iOS application, you are going to need some kind of user authentication service, some kind of service to deploy your API, might be REST or GraphQL, some kind of object storage for your image or video. So if you're working for a large company, maybe it's another team doing that, you don't need to care about that, it's a backend team, it's their thing, and they just give you an endpoint, and hey, it works. If you are an independent developer, small company, or working on your side project, you are also in charge of that. You do the front end and the back end. So I said 2023, no more serverless. Yeah, what does it mean, serverless? No, not exactly. It's not exactly like that. Serverless means you, as a developer or DevOps person, you don't need to manage the server. Someone else is going to manage the server for you. So you can just deploy your code, copy-paste your code to something, Lambda, for example. It's not the only solution, but and someone else, AWS in the case of Lambda, will take care of running the server, updating Linux, putting the patch on Linux, updating the runtime like Node.js, Python, whatever. It's not your responsibility anymore. So there are 4 characteristics, in my opinion, to serverless. First one is no server to manage, we are clear on that. It scales automatically. So let's imagine your application is successful. Yeah, you have 1 million daily active user. Yeah, you don't need to scale the infrastructure. The service provider is going to scale it automatically for you. You don't need to care about that. The only thing, you might pay a bit more, because that's the last one. You pay only for the usage. That's a good news as well, because my old Linux server, I was paying for it even if nobody was calling the API. Even if I have 0 users on my app, I still have to pay for the server. With serverless, you don't pay for the server side if nobody is using it. So it's scaled down to 0, not the storage. Because the storage, you cannot scale it to 0, we still have to keep the storage. But for the compute part, you don't pay it. And it's built in with availability, fault tolerance, so if one data center crash, the service continues to be available. That seems a bit magical. I'm not going into all the details, but these services are deployed across multiple data centers that are distant by a few kilometers. So even if one goes down for whatever reason, plane crash, flooding, power supply cut, fiber cut, the other data centers are still there and your service is still available and you don't have to do anything. It's built into the service. So that's a bit magic. And actually the first time we used Lambda, it feels like magic. So Lambda is one of the many serverless service from AWS. It's a function as a service. As a developer, you write code, you copy-paste your code, or you zip your code and you upload your code, and the magic happens. Something will deploy your code, execute that in a runtime, scale it, making it available for you. And we do support a variety of programming language. Python, Java, JavaScript are the most popular. C#, TypeScript these days, Ruby, Go, I think there is Rust. Swift is not there, but I'll come to that in a minute. You can write Lambda function in Swift as well. Most of the time you are not going to deploy a Lambda function by itself because you need something that call the Lambda function. So if you write an API, you are going to put an API gateway in front of it. So that's the HTTPS termination endpoint. Your client application, your mobile application comes here. Here we do the query parameter, HTTP header, parsing, and triggers the Lambda function. This is your business code. You fetch data from a database, you compute things, you call another API, and you return a JSON that will be returned as an HTTP header response in JSON, and then back to your client application. But it might be a REST API, a GraphQL API. It might be a message arriving in a queue, asynchronous systems. You have an order, a message arrives in a queue, another Lambda will pick up the message, will do something, asynchronous, event-driven architecture. It might be a database change. You have a NoSQL database, a record change, there is a row, can we talk about row inserted in a NoSQL database? It's kind of a record being inserted, and it triggers a Lambda function, so it's kind of a store procedure for the 21st century. Or on batch, like every morning, tomorrow morning, I have I'm the host of the AWS podcast in French. Tomorrow morning at 7 a.m. in the morning, publication of the weekly episode will be triggered by a Lambda function on schedule. So how you create your Lambda function? You go to the AWS console, you need a username and password, and credit card, sorry for that. But Lambda is not very expensive, I will show you after that. Then you go to the Lambda console, you say create function, you give a name, you give a runtime, Python, Java, talk about Swift a bit later. You show the architecture, that's very important, like Intel or ARM. ARM is most cost efficient, so you get better performance for the same price, or cheaper for, the cost performance ratio is better, that's what I mean. And it's good for the planet as well because it consumes less energy, it takes less energy to cool down as well. So if you have a choice, go for ARM if you can. For small function, you can write the code there. Code is quite simple. This is a Python example because so far I didn't talk about Swift and Lambda yet. But you have a function which is the entry point, Lambda handler, given context, and then you return something. In this example, it's for an HTTP API, so I return an HTTP status code and a body with a JSON hello from Lambda. Then you can monitor that, how many invocations there is, how much memory is used, how concurrent invocations, errors, and generate alerts, and etc. How do you deploy that? Most of the time you need, for more complex Lambda function, you have dependencies, libraries, so you put all that in a zip file. You are not going to use the text editor in the console, and you upload the zip file. That's the normal way to deploy Lambda. There are tons of different ways to do that programmatically. This is an example with the CLI, but you can write code, you can write a YAML template. I'm not going to enter into all the details, and Andrea will show you yet another ways to deploy your Lambda function just after this talk. I told you that most of the time you need something else than the Lambda function. You need an API gateway, maybe you need a database in the backend, maybe you need an identity system, so you need other pieces of infrastructure. Yes? So one very convenient way to deploy not only the Lambda code, but also other piece of infrastructure is SAM. So SAM is my friend. I introduce you SAM, NSLondon. This is SAM. SAM stands for Serverless Application Model. And the idea of SAM is that you describe your Lambda function and the infrastructure that it needs in a text file, a YAML document. Here we have two parts. The first part we say, hey, we want a serverless function, so a Lambda function that we run on ARM. The code is there, it's that zip file, and I pass a couple of environment variables. The second part is I want something to invoke that Lambda function. So I create an HTTP API that will react to get HTTP verb on /test as the path. So that's a description of my environment. And then I use the SAM command line, SAM deploy, to generate all the server-side infrastructure for me. So that simple YAML file plus a command line, SAM deploy, will create an API gateway that will invoke a Lambda function. And the code of the Lambda function is inside the zip file, which is somewhere here behind the logo. That's what we call infrastructure as code. You can code your infrastructure. And that's great, because code is a good documentation by itself. I mean, it's super formal. You can version control, so you can check the different version of your infrastructure. That file can be, should be, must be next to the rest of your source code inside your Git repo, and you version control that. So your infrastructure is part of your code. But I hear your question, or you were thinking about that. Yeah, it's great, but how much does it cost? Actually, not a lot. So Lambda is built per millisecond of runtime. Per millisecond of runtime. And the price depends on the size of the micro VM where the Lambda function will run. So if you are using a larger container with more CPU, more RAM, we charge you a bit more than if it is a tiny one. So this is an example for 1 gigabit RAM container running on ARM architecture. And I think it's 7.0 or 8.0, blah, 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 blah. So it doesn't cost a lot. I mean, per millisecond. So if you run the thing for 1 full hour of CPU, it's not even 0.04 US dollar. Then there is a small price per invocation, per million of requests. And the good news is that you get 1 million requests and 400,000 seconds for a 1 gigabyte container, so 100 something hour per month for free every month. So basically you can develop a Lambda for free. You can run a small system, small app on Lambda for free, and you start to pay when your app has success. But if your app has some success, in theory, I hope for you, you have a business model and you have some revenue also to cover that. But for the price of a cup of coffee, you can do a lot of Lambda invocation. There is an additional cost for the API gateway. I didn't factor that out. That costs a bit more, but we are still talking about the same order of magnitude, the price of a cup of coffee per month, no more than that. Yep, I talk about you. That's your experience as well?
No, I don't buy even a coffee. It's free off.
Okay, I told you that I was going to briefly talk about Lambda just to get everybody on the same board. And now let's switch to Swift on Lambda. And I'll show you 2 different ways to deploy Swift code on Lambda. One of them is to take an existing application, like a Vapor application. Everybody knows Vapor, or yes, majority. So it's a web framework that allows to run Swift code and receive HTTP calls and react to that. So package a Vapor, unmodified Vapor app inside the Lambda function. And then in part 3, I will show you how you can write a native Lambda function in Swift. Okay, you have a web app, Vapor, and actually it works for any type of web app. So if you have, I don't know, Express.js, Node.js, or a Flask application in Python, the same technique can be used. So that's all starting point. I have Lambda here, I have an API gateway there, client application is connecting to the API gateway, and I need to put an existing web app there, a Vapor web app there. So how can I do that? To explain you how to do that, I need to explain a bit how Lambda is working. So inside a Lambda function, we are not using containers, we are using micro virtual machines. So the serverless, the serverless promise of not having a server is not real. There are servers, it's Linux machine, and on this Linux machine we have micro VM that are able to start extremely quickly and stop extremely quickly. And your Lambda code runs inside this micro VM. We wrote the micro VM code by ourselves. It's called Firecracker. It's written Rust. It's available on GitHub, so you can look at how it works. That's what I call the Lambda function micro VM. It's this box. The Lambda service receives a call from something, like an API gateway, for example. And inside that micro VM, there is the Lambda runtime engine for each programming language that we support, so Python, TypeScript. And this thing just pulls the Lambda service saying, hey, is there for me an event that I need to process? No. Hey, is there for me an event that I need to process? No. Hey, is there? Yes. And when there is an event, this thing receives the event and then calls your code, the def handler event context that I showed you before, the entry point inside your code. We execute your code, take the response of your code, package that, and return that. Okay, so there is this piece that we do provide, you don't need to write that. The challenge with an existing web app is that the existing web app is expecting, if you think about Vapor, for example, it's expecting to receive an HTTP GET or POST call with JSON parameter. So it does what the API gateway does there. So how can we fit an existing web app there? Because this thing doesn't know how to call an HTTP endpoint running inside your Vapor application there. Yes? I still have everyone with me. I know it's late. You have a work day behind you. So how do you fit your Vapor application there? And what's going the TLS endpoint there? There, it's quite easy. We talked about that already. It's the API gateway. So that's the endpoint doing TLS termination, HTTP, parsing, query string, headers, and everything. And there, we need something to convert the native Lambda method to call a function to HTTP, because inside Vapor, there is another HTTP server running. And there is a mechanism for that. It's called a Lambda extension. So a Lambda extension is a piece of code that you can provide that will act as an interceptor between this and this. So basically, it will intercept all the requests on their way, on that way and on that way, and it can transform the request. And now you get the idea. The idea is to intercept a Lambda invocation there, transform that back to an HTTP call, as it was over there, and make a regular HTTP invoke inside your Vapor application that runs locally inside the micro VM. Yes? Okay. Yes. So your application, unmodified there, including the HTTP endpoint, listening on localhost 127.0.0.1, blah, blah, the port that you choose, and the Lambda extension that call that code over an HTTP invoke. And to deploy everything, Sam, or friend, that will create API gateway, Lambda extension, and this. And I didn't tell you one thing. I told you that you can deploy code inside Lambda as a zip file, but you can also deploy code as a container. So I'm not saying that Lambda is running on container. Lambda is running on micro VM, but we use the format, the container package, as a packaging format, just like a zip file, to deploy code inside the Lambda runtime. So it seems complicated, but it's not. Because you start with your existing app, unmodified. You add one single line inside the Docker file of your Vapor app. Just copy the Lambda extension. You don't need to write a Lambda extension. We did that for you. It's on GitHub. There is a Lambda extension provided. That works with any type of app. Express, Flask in Python, Vapor in Swift, any web app. You package that with Sam, saying, hey, my container to deploy is that, and the API gateway will be there in front, and Sam will create the API gateway and the Lambda. So the whole story takes like 10-15 minutes to explain. It seems complicated, but it's one line to add to your existing Docker file for your existing application. No changes inside your Vapor application. Demo, I have everything there. Sam build, it will build a container. Sam deploy, it will create everything. I have to admit that I accelerated the video a bit. It's a bit slower than that. But it takes like 3-4 minutes maximum to deploy the container, create the Lambda function, create the API gateway, and it gives the address of the API gateway at the end. So I can take a browser, copy paste that address, go to a navigator. I think if you go to a navigator, it will call the Lambda function Yes. So I just call that. And my Vapor app is just an echo. It gives back all the HTTP header it received. So it's my existing Vapor app inside a Lambda function. So the Lambda adapter, the Lambda extension that does the magic of calling an existing web app, it's open source, it's on GitHub, the AWS Labs GitHub, AWS Lambda web adapter. And again, it works with any web application, not only Vapor. Still with me? Yes? Okay. Any questions so far? Yes?
Yeah, so if I have a Vapor app and I'm deploying it through Heroku, is it extremely simple? You make it sound as though it's extremely simple. I have to try it tomorrow.
So you have two different sample ways to deploy your Docker application. Actually, on AWS, there is way more. There are different services that allows you to deploy containers. Lambda is one of them with that technique, but we have native container services, we have Kubernetes, managed Kubernetes as well. So depending on the complexity of your application and the size and competencies of the backend team that will manage that infrastructure, they have different options to deploy container. And yes, if you prefer Heroku or any other, and if you have something that works, basically, keep it. I'm not telling you to switch to AWS. There are many tools to do the same things. Choose the tool that you feel the most comfortable with. And by the way, Heroku is working on AWS, so at the end it will run on AWS anyway. But you're not going to see that. It's hidden by Heroku. Does that answer the question? Anybody else? Yeah.
If the application or the runtime itself have to call whatever is in front of it, as far as I understand, the gateway for events, does that mean that the web application has to run for longer polling?
That's
the gateway?
The Lambda runtime will manage that. So that's totally transparent there. The reality is that we shut down the micro VM if there is no more call to your Lambda function, just to save on resource, and that's why you're not paying if nobody is calling your Lambda function. But I'm not sure about the specific mechanism, but if an event arrived there and there is no micro VM running, we are going to start run automatically.
But do I understand correctly that if there are two HTTP requests in succession coming from the gateway, does that mean it will spawn
two micro VMs?
Two
that's
micro
correct.
VMs, right?
So
So
there is
these
an-
micro VMs, in no way they can be reused between requests.
Yes, they are. So the micro VM here, first we are going to start multiple micro VM if there are multiple requests coming in parallel there. That's the automatic scalability of Lambda. There is a limit per AWS account. I think it's 100 concurrent execution of Lambda, but it's a soft limit you can ask. You can open a ticket to support and ask to increase that limit. It's just to avoid to burn yourself if you make a programming error on the client side. So that's the first thing. Second thing is that we are going to shut down the last micro VM if there is no more request there, but we are going to restart the micro VM automatically if there is another request coming. And that's why there is a phenomenon on Lambda, or maybe it's too much detail, but the very first time a micro VM is starting, the latency for the invocation might be a bit longer because we need to initialize the micro VM, that's a few milliseconds. But most of the time we need to initialize that, and that phenomenon really depends on what you are doing there. For some programming language, Java, I'm looking at you, it might be quite long because of a Java application with Spring Boot, you download or you have to load tons of classes to get it running.
It's clear, thanks.
That's the phenomenon. That's called cold start on Lambda. It's not specific to Lambda. If you look at Azure function or Google function, it's the same.
I noticed in your server response, you return the IP, and so that's the IP of the client that's calling. So with the plugin extension, we use Lambdas quite a lot. We don't get the user IP or any session data. Do you also forward through the rest of the requests, like cookies and other things that come?
So the Lambda extension takes. So if you use an API gateway there, all the HTTP headers will be propagated to the Lambda function, and the Lambda extension decodes that and recreates HTTP header for the HTTP request that will arrive there. So you will have the origin and JWT tokens or like that.
And I'm assuming because it's Lambda, it typically has like a shelf time after a certain amount of time. It's
Oh, yes.
not really suitable for sockets.
Yeah, that's a good question. I forgot to mention that. So Lambda function runs for 15 minutes. After 15 minutes, we shut down the micro VM. So any long running task, like a batch or a WebSocket connection, is not a good fit for Lambda. Then this is what I said. There are many different ways to deploy container on AWS. Then you can use another one. So it's more for it. That's why I'm talking more about API, like short-lived request, less than 15 minutes. Okay, native Lambda function in Swift. Sorry, I have to go through all the animation again. Oops. Write your own Lambda function in Swift. Is it possible? Yes, it's possible, thanks to something called the AWS Lambda custom runtime. So again, to explain you why it is, you need to know a little bit more about how Lambda is working. So a Lambda custom runtime is a runtime that you provide, and that includes your handler code, the code that you will write in Swift, in Python or something. And remember I told you there is something polling the Lambda function, the Lambda service, polling for event and forwarding the event to your handler code. And that's the role of the custom runtime. So custom runtime is essentially an executable that we call Bootstrap, and it's an infinite loop that will call a REST API on the Lambda service saying, hey, do you have something for me to process? That's the get, the next event. If there is something, this thing is responsible to call your code. Then your code returns something. This thing receives something and posts it back to the Lambda service as a REST post API code. Okay? This happens inside a micro VM running on Linux. So any programming language that runs on Linux can be run on Lambda. You just need to write this piece of code, which at high level in theory is not too complicated. It's an infinite loop calling HTTP get /next. If there is something, you call something there, and when you get a response, you call HTTP post response. That can be complicated. So I'm doing that. I wrote one in shell script. It works. So you can write a Lambda function in shell script. We have partners that wrote PHP custom runtime. We have partners that created a COBOL custom runtime. So it's possible to run COBOL code compiled to Linux in a Lambda function. Very powerful to migrate mainframe application. Anyone working in a bank? No? Okay. So for Swift, it's exactly the same. We need that bootstrap code, that infinite loop, making HTTP REST call, and that invokes your Lambda function code. Good news is that you do not need to write that bootstrap code. Apple wrote it, so there is an open source Lambda custom runtime on the Swift server Git repository. It's implemented with Swift and IO. It's a quite fast, efficient way to actually integrate your Swift code inside a Lambda function. So if you want to write your first Lambda function, you create a package. You have to create an executable. I call it HTTP API Lambda. So far, so good. Then I had the dependencies, and I had two dependencies. One of them is the Lambda runtime provided by Apple. And Apple created another repo, another library that allows to represent in JSON the event coming from an external source. If there is an HTTP gateway, the HTTP gateway has a specific JSON format to pass to the Lambda function. If it is a message in a queue, it will be another format. So all the event source, the traditional event source for Lambda, has been modeled as Swift struct by Apple. So that's the second dependency. Then I write the code. I use the main for my main struct that will be executed. I implement the simple Lambda handler protocol, and I just have one function to define. It's handle, just like the one in Python, with an event. In my case, it's an API gateway request. I receive a context, and I return an API gateway response. inside that handle, you do exactly whatever you want. You call the database, another API. It's up to you. The only thing you are responsible for is to return an API gateway response. So here it's my echo type of demo. I take all the HTTP header, I log that, I add an HTTP header, I encode in JSON the event I receive, and I put the event I receive as a response, and I return the HTTP response, status code, okay, headers, and the body JSON. Simple demo, very straightforward. I can test that locally inside Xcode, so I don't even need to exit of Xcode. Here I have an example. It's one of the examples of the repo from Apple. There is an iOS application and there is a Lambda function. So I have two targets, two executables, the iOS application and the Lambda function. For the Lambda function, I add an environment variable that says local Lambda server enabled to true. And when that environment variable is on, the Lambda custom runtime provided by Apple has a mini HTTP server. So if I execute that, it will wait on localhost for 7,000, and I can put that endpoint inside my iOS application to test the communication between the iOS application and the Lambda code running locally on my Mac. So here I change the console to see what's happening on the server side. You enter username, password, register, and you see that there is a receive request which is logged from the Lambda code. So that's very convenient because you can put a breakpoint and debug your Lambda function just like you would do with a typical library there. Then it's time to build that and to package that, and this is where it's a bit more complicated. Good news, again, there is a plugin that will do the build for you. In the very first version, it was a bit complex because remember, Lambda it's Linux. Your Mac, it's not Linux. So you need to compile for Linux. And you need to ship all the dependencies, the runtime, the libraries inside a zip file, then deploy on Lambda Linux. So there was a lot of shell script, it was complicated. And Apple adds to their repo a Swift plugin. So a plugin is something that you can execute from the Swift command line with Swift package. And then the name is archive. And it will create a Docker container with Linux, compile your code into a Linux executable inside the Docker container, take that, zip that, and at the end you have a zip file that you can deploy on Lambda. So only one command, Swift package archive. Disable sandbox is because there is a sandbox for the plugins, and Docker runs on the network socket, so we need to be able to communicate with the Docker team. How does it work? I just explained it. We take a Docker file, and inside the Docker file, we are going to compile your Lambda code for Linux, and at the end, it creates a zip archive that you can deploy on Lambda. How do you deploy that zip file? Because most of the time, remember, you want to deploy an API gateway, you need to deploy an identity system, a database, so you need more than that. So I tried to write another plugin. If you look at the repo now, it's in a pull request. It has not been approved yet. But if you look at that branch of the pull request, there are two plugins. There is the packager plugin, so the archive, the one that creates the zip, and I create a deployer plugin that allows you to deploy the zip file to Lambda from Swift using Swift package something. And the idea is we need something to actually describe what we want to deploy in addition of the Lambda function, the API gateway, the identity system, the database. So the way it works, I'm talking a bit too fast. The way it works is that it allows you to define, using the Swift programming language, the dependencies of your Lambda function, and it will generate a SAM file for you automatically. So the idea is that next to your Lambda function, you add a file called deploy.swift. And that file uses the Swift syntax to create a deployment descriptor, to tell us what you want to deploy. For example, I want to deploy a function, the name of the function is this, the event source of the function, it's an HTTP API, on the get method /test with environment variable. Hey, it looks like the SAM file I showed you earlier. Yes, it's not by chance. And what the plugin does, it detects that deployed Swift file, it compiles it and generates a YAML file automatically. So deployment descriptor, you import the deployment descriptor, you give a description, you declare your function, you give a name, you add one or multiple event source, you add environment variable, and at runtime, it will generate a SAM file. So the plugin will read and compile that Swift file to generate that YAML file, and then it will deploy the YAML file for you automatically on Lambda. Are you still with me?
Yes.
Okay. So again, SAM deploy, and it creates all the infrastructure automatically for you. You can test locally thanks to SAM as well. So SAM has a mini container to run the Lambda function locally. So you can invoke a function locally. SAM local invoke. You give the template that has been generated. You give the input JSON, and you can see everything that happens inside the Lambda runtime. So that's a lot of information, but there is one important there. It says HTTP. That's the debug from my Lambda function, which shows that the Lambda function has been correctly invoked. So I told you this second part is just a pull request right now. I'm trying to get that approved, but I have no idea if it will be or not. I have tons of ideas to improve it, to support more part of Lambda, to add user authentication. Collect your feedback if you're interested. Try it, give it a try, and tell me how we can do that better. So, I'm done. We talk about Lambda. What is Lambda? Serverless as a function, or code as a function. I talk about SAM, that allows you to describe an infrastructure, like an API gateway, to deploy it together with your Lambda function. Then I show you how you can combine SAM and Lambda to deploy an existing Vapor application. No code change required, just one line change in the Docker file. And then I show you how you can create a native Swift function in Lambda, and how you can archive it with the archiver plugin and deploy it with the deployer plugin. And yesterday, Apple released something new, and I didn't have the time to look at it, but it's a Swift Open API generator. So the idea is to start from an Open API YAML description, so a description of your API, generate the data structure in Swift, generate the Swift server-side code, and they have different plugins, one for Vapor, one for Hummingbird, which is another HTTP lightweight framework for Swift, and generate the Swift client code. So I just played a bit this afternoon. I tried the sample code, the example, it was working. I didn't look at I didn't try to develop something myself. But it's another approach to deploy Swift on the server side. It looks promising. I like the fact that they start with OpenAPI, because that's something that fits well into HTTP gateway as well. So when you create an HTTP gateway, you can give them an OpenAPI definition of all the HTTP verb and params you're going to receive. So maybe there is something to do there with Lambda as well. But that's brand new from yesterday. I discovered that this morning when I woke up, so just to mention it. So what are you going to build with Lambda? That's my question. No, seriously, thank you. I'm available on most of the social networks, Sebsto, S-E-B-S-T-O, Mastodon, Twitter, the other new Twitter, Blue Sky, LinkedIn, and scan this. It's 3 anonymous questions about this talk, how we can make this talk better. If you learn something, give us your feedback, share your feedback. And after you receive a $25 credits that you can apply on your AWS account, so you can try all these for free. Remember, it's less than a cup of coffee per month. So with $25, you have several months of developing and testing and even running small projects into production. Thank you.